Welcome to today's tutorial. In today's lesson, we will cover the one sample t-test in SPSS. And so the first thing that I'll do is I'll open SPSS. I've opened it already and closed the splash pad when it appeared, but we've already created a data set. And so I will go to File, Open, and right here our intro video SPSS data. And so I'll open that data set. And here we have our data set, which included our participant ID, gender, male or female, their height in inches, and weight in pounds. And we'll go over in just a second how we entered all of that. And we'll have a quick refresher in the different views of SPSS. But again, today's lesson is on the one sample t-test in SPSS. And the purpose of this is to compare the average or the mean of a sample group to a known population mean. So for example, you might want to determine if the average height in our sample is different from a known population height. So I pulled the CDC's data for average height, and I got 66.25 inches. And so we can compare the average height in our sample to this known population mean to see if it differs, but more importantly, to see if it differs significantly from the population mean. So as a quick refresher, in SPSS, data entry is managed through two key views. You have data view and you have your variable view. In data view, what you're seeing is the actual data values in a spreadsheet format. And you can see the spreadsheet formatting where each of the rows represents a different participant or a case, and each column represents a variable such as ID or gender, height, and weight. You'll see that this data set already has the values entered for each participant and for each variable with these cases and values excluded purposefully. And if I wanted to include another participant, I would simply click in the cell and provide them an identification number. If that participant was male or female, let's say they were male, and then height and weight values. Now, we have previously coded gender, one for male and two for female. And so if I switch over to variable view, you can see how we've defined the attributes of each variable. So for each column in data view, we specify the details for that variable in variable view, such as the name of the variable, the type of variable that it is. For the labels, we added a bit of description. So for ID, we said that it was identification numbers. For gender, we said male and female, height in inches, weight in pounds. We coded gender as either male or female, and we told SPSS, when I clicked on the ellipses right there, that a value of 1 is code for male and a value of 2 is code for female. And finally, we determine the measure. For this data set, Um, we have nominal for ID and for gender because these are categorical. And we have scale as the measurement for height and weight, as these are continuous measurements. As a reminder, SPSS requires very accurate setup in variable view to properly analyze and interpret data. So ensure that each variable is clearly named and coded. And this setup allows SPSS to recognize height, for example, as a continuous variable that we can now use in our analysis. So in a one sample t-test, we compare the mean of a single group to a known or hypothetical mean. For instance, we might ask, does the average height of a sample group differ significantly from an expected population mean? In this case, we're using an averaged height value of 66.25, and that was derived from both male and female height data from the CDC. So a height of 69 inches for males and a height of 63.5 inches for females would average 66.25. So that's where I derived that value. So you can think of an example from education where we could compare a sample to a known mean. For instance, you might compare test scores of a class to the average score on a state or national standardized test, such as the SAT or the ACT, to see if your group performs above or below the average. So to perform the test in SPSS, we'll go to Analyze, Compare Means, and then One Sample t-test. So if I go to SPSS, I'm going to Analyze, Compare Means, and then over to One Sample t-test. And so in the one sample t-test window, you're going to select the variable you want to test. So let's use height. And we're going to move that over into the test variable box. Now we need to set the test value right down here, the test value, which represents the hypothesized mean for the population. In this example, we're comparing to a population mean height of 66.25. So, and that's based on the CDC's data. So we're going to enter 66.25 in the test value box. Okay. Pause here, make sure that you've set your test value, double check that the variable you're testing is in the test variable box, and that your test value is correctly entered. Go ahead and click OK. After running the test, you'll see SPSS has generated a few key tables. The descriptive statistics table will show you the sample size. It will show you the mean or the average. So in this case, 65.8. The standard deviation, 2.39. And the standard deviation or the standard error of the mean. The next box is our one sample test box. And this box or table provides the t-value negative 0.594, the degrees of freedom, and the p-value. In our case, the test value is set again to 66.25 as derived from the CDC's height data. And so now we need to interpret these results. When we're trying to determine if the sample mean is significantly different from the test value. So to do that, we'll examine three indicators: the t-value, the p-value, and the confidence intervals. So looking at the SPSS output, we see a t-value of negative 0.594 with 9 degrees of freedom, and a two-sided p-value of 0.567. Since this p-value is much larger than 0.05, it indicates that the sample mean does not differ significantly from the test value of 66.25 inches. Additionally, the 95% confidence interval for the mean difference ranges from negative 2.163 to positive 1.263. Which includes 0. That further supports the conclusion that there is no significant difference between our sample mean height and the CDC average. The final thing that we would do is to compare the t-value to a t-value table, which was primarily the method by which you would determine statistical significance. I'm Googling critical t-value table. Specifically, this is the one that is uploaded for you in your course materials. And so if I visit this t-table, again, if we go back, our t-value is negative 0.594 with 9 degrees of freedom. And so for a t-value with 9 degrees of freedom of 0.54, right? And so we would need to exceed these critical t-values for it to be significant. And you can see that our t-value of negative 0.594 is nowhere near exceeding these critical t-values. All right, so for a two-tailed test, 0.5 would not indicate significance. It would need to be 0.05 or less for significance. And so for our value of negative 0.5, we would definitely be in the realm of not significant over here in this area, right? Less than 0.7, right? We're in negative 0.5. So again, a determination of not significant at all, right? Technically, we would need a t-value of 2.262 to reach significance at 0.05 with 9 degrees of freedom. So again, that is the original or older method of determining significance, right? So comparing that critical value from a t-distribution or a t-table. Again, we can look at the p-value and confidence intervals to further make that determination that, yes, in fact, this is not a significant difference, right? Not a t-value that reaches a level of significance. The two-sided p-value is greater than 0.05, and the confidence interval includes 0. All of those together would indicate, again, not a significant difference. So going back to the output, in our case, the average height of our sample group was not statistically significant in its difference from the CDC's average height of 66.25. Right, the p-value again is 0.567, which is above the significance threshold of 0.05, and the confidence intervals included 0. All of that together tells us that our sample height is consistent with the population mean based on CDC data. And that's how you run a one-sample t-test in SPSS. You've learned to compare a sample mean to a known value, interpret the t-values and the p-values, and determine if the difference is statistically significant. Stay tuned for the next tutorial, where we'll be covering additional statistical tests in SPSS.